Hello friend, in this video I will be talking about Python and OpenCV for the purpose of face detection. Right now I'm in Google Colab, and in my Google Drive I have got couple of folders. One is called Cascade, another one is called Images. So from these folders I will access few files. So over here I have imported OpenCV, CV2 I have imported over here, and these two lines will actually connect the Google Drive with my Colab, and it has already mounted over here. Now just now I said that in my drive I have image folder where I have a file called people1. That is what I'm trying to read, and as I run my code over here it will show me the shape. So what does this shape all about? It is 1280 by width and 920 by height, and it has got three channels. Three channel means red, green and blue. So I want to see this image which it has detected, and for that reason I'm using Google's Colab patches for CV2 Image Show. And as you can see right over here, the image is already been shown over here, but let me rerun the code once again, and this will show you the code, the image that is there in the Google cloud. And now one more thing I would like to add: if you are working on only CV2 in your local system, then CV2 underscore image show or this particular function would directly work on. But if you work on Google Colab, then you need to give an access to this particular package, and from there you will be getting the image show method. And here it goes. So this is the method which, this is the picture which this particular method has read, and it has shown you that the width and the height it has shown you, and it is a colored image which is pretty high resolution, and it is not actually so effective for the machine learning. So for that reason what we have to do is that we have to resize it, and that's where the CV2 resize function comes in. And I resize this to 800 into 600 width, and here as you can see it's showing the tuple or Python tuple, whatever you call it, which has got the width, the height, and the number of color channel is 3. And here again it is showing me after it has resized the image from the above original image. So this is what the new size of the image is actually. Okay, now let's come down over here. I would like to show you something, that if I go for 600 into 803 channel, the total I would be getting is this. And if I would have gone for Grayscale, which will have only one channel, then I would be getting this. And if I make a minus of these two, then this is the information that differs. So as we can see over here, the Grayscale image is much lesser in weight, and that would be more effective. So for that reason I have to convert using the CV2 function, CV2 package, convert color and the original image and the BGR, so that means blue, green and red, to grayscale, and after doing that I would be getting the grayscale image. And in this case there would be only one channel. So let's calculate the shape and let's check the shape, and it will be showing me that there is no channel present. That means by default it is just only one channel, and this is more preferable in working with the image classification or face detection, whatever. So I'm working on the CV2 Haar cascade classifier, and as I said that in my drive this particular trained file is already present, which is available on internet, Haar cascade.frontal face default.xml. What do you mean by frontal face? If you look over here, these faces are facing front, but this is the side face. Okay, this particular face won't be detected. So we will see that how there is a drawback in this particular classifier, that when you have a face facing front to the camera, then it's working pretty well. But if you have got a side face like this, we know that this is a human being, but my classifier won't be able to detect this particular face at all. So we'll see even that also. So let me compile this particular file, and the frontal face detected XML file has got now saved in the memory in the form of this particular reference. So now what I'm going to do is that I'm going to give a call to the detect multiscale method, and I will be passing my grayscale image over here. So the reference of the Haar cascade is giving a call to the detect multiscale function, method I'm passing the grayscale image. Now this particular method is very amazing. It goes for multi-scales. Multi-scale means it would resize the image so that it can figure out the phase where exactly it is present in the image. So resizing means it can increase the width, it can increase the height, it can shrink also. So zoom in, zoom out, all these things will be done over here so that it can figure out the phase. So the different dimension it will create for the detection. So let me call this particular function. After that, the object will get detected over here. Here is a reference of this is going to be printing a matrix basically, which will show me where exactly the object is present. Okay, let me just do one thing which I can fire over here. Let's check out this particular matrix and let's see what it has got actually. Yes, now let me run this particular statement once again and we will see a wonderful matrix over here. Now see the matrix. It has got how many rows? 1, 2, 3, 4, 5 and 6. Well, you might be wondering why 6, because there are 6 faces, 1, 2, 3, 4, 5, 6. Well, not exactly. I have seen that this particular phase won't be detected, but some extra phase, actually extra object got detected. I shouldn't say extra phase, extra object got detected. We will even see that also where it is detected. So how this particular row actually goes? Well, this row is like, this is the x-axis and this is the y-axis. That means here the object actually starts, and this is the width, this is the height. Okay, that means it's a squared object. So that means here the starting of the x-axis of the image, that means here it is detected the phase, and here is the y-axis and the width and the height. Again, the phase has been detected the x-axis, and the y-axis is the coordinate that would pinpoint where the phase has been, just exact starting position you can say. So the width and the height will be stated over here. So I can show you this. What does this particular matrix mean? So what I will do is that I will uncomment this line and I will just comment this one, and let me show you something really amazing. So I have gone for extracting the data from this tuple. From this matrix, and it will be stored in this particular tuple, you can say so, where this would go as a x, this would go as a y, this is going to be as a width, this is going to be as a height, and that's what it will pinpoint. So let me just run this particular code and you will see really amazing stuff over here, and how exactly this x and y is going to work. That will be pinpointed over here. Okay, it didn't show me that one. It just showed me the record only. No, I don't need to see the record. What I will do is that I will uncomment this line and I will not add this x addition. I will not add. Let this be like this for a while. Yeah, let it be like this, and let me now compile the portion just to show you where exactly the dot has been detected. Let me show you that. It's a really very cool one. Look over here. This is the coordinate which is referring. This is the x coordinate and y coordinate of this particular phase. This is there is no width and there is no height. The square is not getting framed, and this is the color resolution, and this is just the size of the dot, you can say so. And again, the next that means this is, just imagine this is the x-axis, this is a y-axis. So that's how the thing is detected. Again, this object has got x-axis, y-axis, maybe this one, this axis, this object also maybe this one. In this way the plot has taken place. Now just see over here, one extra spot has been generated. This is something which is not actually a phase, but some way or the other my application is saying that this is a phase. That's what it is thinking, it is assuming, but actually this is not a phase. So we will make some modification about this. Okay, so that's how the dot got generated, just to show you where exactly the phase has been detected. So now what I will do is that I will add the width. So plus w I will do, that will add the width, and I will go for plus h, that will add the height, and that will give me a very nice square which will show me where exactly the phase is present in the image. And let's see how that is going to generate it. And here it is. And look, this is what I was saying, that the system would detect this particular object. It's assuming that this is a phase, but this is not a phase. We know it very well, and for that reason what we have to do is we have to add one more extra parameter, and that is called scale factor. So what this scale factor would do, already I said that the detect multiscale would zoom in, zoom out the image to figure out the phase, but still from additionally we have to add this particular scale factor. And after doing some testing, I found that this particular value is exact value where it would detect only the phase and not any other object. Well, the scale factor would start from the value greater than 1. So if you just give 1, that will give an error, and you have to keep on just trying to see which particular scale unit will actually be effective to figure out this particular shape and object. Okay, so let me compile this particular statement once again, and here now we would see that the exact the objects object, I mean the face, has been very nicely, very sharply detected. And I was talking about the width of the line. So if I make it just 2, the thickness of the line will decrease, and this would look pretty good now. And as I was saying, that the scale factor you can try out. If you go with a scale factor of just 1, you're going to get an error over here because it should be greater than 1. See, it's saying that it should be greater than 1. Okay, look over here, that's what it printed out, the scale factor. Okay, so you have to go for the value greater than 1 and not exactly 1. So I kept on trying, and I found that 0.9 actually works pretty well. And if I go for a larger value, then I saw that the figure of the face was not detected correctly, but this is giving me a very nice outlook. Okay, but at the end of the day, what I would say that the OpenCV is working pretty good as far as the frontal face is concerned. But if there is a side face or a profile face, you can say this is also profile face, where there is an outline, you don't get the exact shape of your face, there where frontal face of Haar cascade classifier will actually fail. And that brings us a new scope, a new dimension in our career, and that is called neural network or the deep learning. So over there we can resolve this kind of problem, but that is more sophisticated. But before we get into this, we can try out all these kind of sample examples. In fact, I have thought few more examples on Haar cascade classifier that would give us a much wider idea that how this particular XML file is really working on. Okay, so that's all from this video. See you soon.